Okay, this is the AP Calculus AB 2025 exam free response questions. This is my sample answer for number 6. Says, consider the curve G defined by the equation y cubed minus y squared minus y plus 1/4 x squared equals 0. Part A says, show that dy dx is equal to negative x divided by 2 times 3y squared minus 2y minus 1. Okay. So we are going to, for part A, we're going to take the derivative of the curve G in respect to y and in respect to x. So we have y cubed minus y squared minus y plus 1/4 x squared equals 0. Then taking the derivative, we have 3y squared dy minus 2y dy minus 1 dy, or just dy, plus the 2 is going to come down and multiply by the 1/4, giving us 1/2. So this is going to be 1/2 x dx equals 0. Okay. I can take a dy out of these first 3 terms. So this gives me dy times 3y squared minus 2y minus 1 plus 1/2 x dx equals 0. Then I can subtract the 1/2 x dx to the other side. So I'm going to do that over here. Dy times 3y squared minus 2y minus 1 is equal to negative 1/2 x dx. Okay. Then I would divide both sides by dx and then divide both sides by the 3y squared minus 2y minus 1. So that gives me dy dx is equal to negative 1/2 x over 3y squared minus 2y minus 1. Or I could rewrite this as negative x over 2 times 3y squared minus 2y minus 1. And that would be my answer to part A, proving that dy dx is in fact equal to what we got. Part B says there is a point P on the curve G near 2, negative 1 with an x coordinate of 1.6. Use the line tangent to the curve at 2, negative 1 to approximate the y coordinate of point P. Okay, so in order to do this, we're first going to use our dy dx equation, and we are going to plug in our x and y values, so that 2, negative 1, into the equation for our dy dx. So this gives us negative 2 over 2 times 3 times negative 1 squared minus 2 times negative 1 minus 1 is equal to negative 2 over 2 times 3 times 1 plus 2 minus 1, which gives us negative 2 over 8, which gives us negative 1/4. This is going to be used for our slope, or our m value. Then we're going to write the point slope formula of y minus y1 is equal to m x minus x1. And I'm going to be plugging in the values 2 for x, negative 1 for y, and for m, our slope, negative 1/4 that we found from the dy dx. So this is y minus a negative 1 is equal to negative 1/4 x minus 2. So this is y plus 1 is equal to negative 1/4 x plus 1/2. Subtract the 1 over, y is equal to negative 1/4 x minus 1/2. And now I'm plugging in the 1.6 for my x value. So y is equal to negative 1/4 times 1.6 minus 1/2, which is equal to negative 0.9 as my y value. Part C says for x greater than 0 and y greater than 0, there is a point S on the curve G at which the line tangent to the curve at that point is vertical. Find the y-coordinate of point S. Show the work that leads up to your answer. Okay, so this is part C. First, I want to note that we said that x is greater than 0 and y is greater than 0. So what we're going to try to find is the factors for the 3y squared minus 2y minus 1, which was our denominator of our dy dx. So this is 3y squared minus 2y minus 1 equals 0. Okay, factor by grouping. This is 3y squared minus 3y plus y minus 1 equals 0. Take out a 3y, we're left with y minus 1 plus 1, y minus 1, which means I have 3y plus 1, y minus 1 equals 0. Okay, this means I have 3y plus 1 equals 0, which means y is equal to negative 1/3, and y minus 1 equals 0 implies that y is equal to 1. Well, remember, we can only have our y value greater than 0 and negative 1/3 is less than 0, so that's not a possible answer, which means our only possible answer here would be y equals 1. Last part, part D. Let me go back up here. A particle moves along the curve h defined by the equation 2xy plus natural log y equals 8. At the instant when the particle is at the point 4, 1, dx dt is equal to 3. Find dy dt at that instant. Show the work that leads to your answer. Okay. So this is part D. Okay. I am going to take 2xy plus natural log of y equals 8 and take the derivative respect to t. I'm going to note that I know that dx dt is equal to 3, and I'm using the point 4, 1. So I am going to take the derivative to respect to y and to x. So I have 2x dy dt plus 2 dx dt plus 1 over y dy dt is equal to 0. I know that dx dt is 3, and I know that x is 4 and y is 1, so I have 2 times 4 dy dt plus 2 times 3 plus 1 over 1 dy dt is equal to 0. So I have 8 dy dt plus 6 plus dy dt equals 0. So I have dy dt of 8 plus 1 equals negative 6. So dy dt is equal to negative 6 over 9, which is equal to negative 2/3.